Hey everyone, so let's solve this Leetcode medium problem, a maximum key to sort a permutation. So like the problem is like purely observation based. We'll try to make some observations and like there is not much logic involved to it. Once you are able to observe some things, then means the code as well as the implementation is like pretty simple. Okay, so let's read the problem statement. So we are given an integer array nums of length n, where nums is a permutation of the numbers in the range 0 to n minus 1. So that means all the integers from 0 to n minus 1 will be occurring once in this nums. So it has n distinct elements and all these distinct elements are from 0 to n minus 1. Now we can swap elements at indices I and j if and only if nums of I and nums of j is equals to k. Okay, and this AND operation is the bitwise AND operation that we have. So if the nums of I and nums of j is equals to k, then we can perform a swap operation. Now we need to find out this maximum value of k such that the array that we have can be sorted in non-decreasing order. That means we need to sort the given array in increasing order. So this is a permutation of 0 to n minus 1. So what is the maximum value of k that we need such that we are able to convert it in this form 0, 1, 2, 3, 4 till n minus 1 so that this becomes sorted. So we need to find out this maximum value of k, and if nums is already sorted, then we'll simply return 0. Okay, then we'll not be performing, means this k will not be using. So if it is already sorted, we'll simply return 0. If it is not sorted, then we need to return the maximum value of k such that we perform some swaps using this particular k and we are able to sort it. And the length of nums can go up to 1e5, and obviously nums of I will be lying from 0 to n minus 1, and it is a permutation of integers. So let's see the given input. So for example, if we have the nums as 0, 3, 2, 1. So what is the final configuration that we want? We want it to 0, 1, 2, 3. So we see like this element is good. So we'll not be touching this element, as well as this element is also in its good position. So we'll not be touching this element as well. So we know what swap operation will be performing. We need to perform 3, and so we need to perform a swap operation between these two values. And simply we know like 3 is represented by 1, 1, and 1 is simply 0, 1. So the AND operation is simply what? It is simply 0, 1, which is equals to 1 only. Okay, so hence in this case, if means nums of means 3 and 1 equals to 1, and which will be, this will be the k that we'll be choosing, so that we are able to swap these two values and convert this to 0, 1, 2, 3. Hence the value of k that we'll be choosing here is 1, and that will be the maximum possible value. Okay, so this will be the scenario in this case. Let's see another input. So we are given 0, 1, 3, 2. Okay, so the array is 0, 1, 3, 2, and we need the final configuration as 0, 1, 2, 3. So we see like in this case 0 and 1s are present at valid positions, so we will not be touching these two values. Now we need to perform a swap in these operations, so we simply find out the value. 3 is 1, 1 and 2 is 1, 0. So when you perform the AND, it is simply 1, 0 only. Okay, so AND operation gives us 2, so the k that we'll be choosing here will be 2, because these values nums of means 3 and 2 is equals to 2. So this will be the k value that we'll be choosing, and that will be the maximum possible, because we'll be able to perform a swap operation between these two values, since means 3 and 2 is equals to k. So in the operation means in this case the k that we'll be choosing is simply 2. Let's see another input. So we are given 3, 2, 1, 0, 3, 2, 1, 0, and we need the final configuration as 0, 1, 2, 3. So what do we have here? We see like none of the positions here are like in already in their correct position. Okay, so we'll definitely need to, in this case we need to swap each element at least once, right? We'll definitely need to swap each element in this array at least once. Will be definitely performing a means AND operation in each of the elements. Okay, so what we means how will be choosing the key? So what do we have? We have 3, 2, 1, 0. Now we want to bring this 0 to this position. Okay, so since we need to bring this 0 to this position, we know like if we need to move this 0, so will definitely be means nums of I is this 0, and we'll have nums of j as these of the values, either like 3, 2 or 1. Now we know if we take the AND of these two values, it will be simply 0 only. Okay, it will be simply 0. So the best case scenario will be to means take the swap operation with 3. So we perform the swap, and since we know like this k means and will be 0, so we'll simply take the k as 0 only, because since there is a 0 present and 0 is not at its correct position, so we'll definitely need to move this 0, and to move this 0 we need to satisfy the condition that this 0 and something should be equals to k. So obviously if we are doing the AND of some element with 0, the result will be 0 only. Okay, so in this case the k will be simply 0, because we perform this operation. So 3 will be 1 1 and 0 is 0 0, so obviously we'll be getting 0, as well as we can perform a swap here as well, because 1 is simply 0 1 and 2 is simply 1 0. So here also the AND is equals to 0, so we can simply perform a swap operation between these two values as well. Okay, so as we'll use k equals to 0, and we'll be getting the final sorted list as 0 1 2 3. So let's try to make some observations on this case. Okay, obviously like some brute force trying in some brute force manner means it may become complex, because there is not a clear indication of how we'll be means choosing this k, and for a particular k how we'll be deciding whether it is possible or not. Okay, so we know like if we have means the element should be in the order of 0 1 2 3 till n minus 1. So this is simply like indexes. So it means in the final what do we want? The nums of I should be equals to I. This is what we want. Okay, now if we have the given nums, we know like the elements which are already at correct position will not be touching, not touch, will not be touching those elements. Okay, only those which are means away will be performing swap operation, swap at least once. We know that. Okay, so we'll performing a swap operation at least once. So if suppose this means the k that we'll be using is denoted by this value. Okay, the k that we have chosen is this value, and there are some values from 0 to n minus 1. Some are at like correct positions, and some are not at correct positions. Let's like denote those values as suppose this x1 x2 x3 and so on xm. These are the values which are not present at their correct positions, and we need to perform a swap between these such that now they are means in their correct positions and in a sorted fashion. Okay, so how will we like perform a swap operation? We will perform a swap operation. Suppose we perform a swap operation between x1 and x3. So the value will be x1 and x3 should be equals to this k. Okay, this should be equals to this k. And now let's try to see it in the form of bits. So if the result of x1 and x3 is equals to k, then that means this k that we have is a submask of x1, as well as it is a submask of x3. That means it will have some of the bits of x1 means which are set bits of x1, and for x3 also it will have some of the set bits of x3 also. Means it will have no new bits which are not a part of x3. Okay, it will only have those bits which are means set in x3. So it will be submask of x1 as well as it will be a submask of x3. So that means if you simply take x1 and k, it will be the simply k only. And as well as if you simply take x3 and k, then this value will also be k only. Okay, so what does this means represents? We know like we'll definitely perform at least one swap operation in all of these values. Okay, we know like it will be will performing a swap operation in all of these values. So we know that x1 and k should be equals to k, x3 and k should be equals to k. So x1 and k, x2 and k, x3 and k, and so on till xm and k. These all values should be equals to k, right? And now what do we want? We want to find this k. What will be this k? Okay, so let's try to take AND of all of these equations. Let's try to take AND of all of these equations. So what will become? It will be simply become x1 and k, then x2 and k, and so on till xm and k. And it will be equals to what? K and k and k, which is simply means equals to k only. Okay, and now we see like since here also this k is present multiple times, so that means we can simply take the result of values of these. So it will be simply what? X1 and x2 and x3 and so on till xm. Okay, and we'll be taking its AND with what? K and k and k so on, km m times, and this should be like equals to k. Okay, Now we know this value should be is simply k only. Okay, this value is simply k, and this value is some suppose variable y. So what do we want? We want to take y such that y and k is equals to this k. So obviously what will be this y? This y should be some supermask of k obviously. And since we want to choose this y, means this k, as max as possible, so we'll make this y, since we want to make this k as max as possible, so we'll be choosing this y in such a manner that this is also equals to this k only. Okay, so that this means whatever this supermask is, all of these bits are utilized by k only. Okay, so from this we encountered that we can simply take this y as k only. So that since it is representing a supermask, and that supermask should be equals to k, because we want to maximize the k so that it has all the set bits of y. Okay, so since the goal was to maximize this value of k, we'll be choosing is y in such a manner that these two values are the same only. Okay, so that means after taking add, the value doesn't reduce. Okay, it remains the same. So that means this y should be equals to k. And what was y? Y was simply x1 and x2 and x1. So x1 and x2 and till xm. So the final result that we got is we simply take the AND of those positions. We simply take the AND of elements which are not at correct position. Not at correct position. So these are the elements which are not at correct position, and then we simply take their AND, and that will be the maximum possible k that we'll have. Okay, so what is the algorithm? We'll simply find out those elements which are means nums of I equals to I, that means it is in correct position. So for all those elements for those nums of I is not equals to I, this means this is not in correct position, so we'll simply maintain and take the AND of all these elements. Okay, so we'll take an AND of all these position elements and we'll simply return the final AND. Okay, and means along with that we also check like if there exists no such value, that this means all the values are initially in sorted order only, then we'll simply return 0. Okay, so we can maintain a separate check for that. So this is like the overall observation as well as the derivation of this problem. Let's try to see the code. The code is pretty simple. I hope the discussion was quite fruitful and you got to learn about how do we manipulate the statement and try to solve the problem. So let's see the implementation. The implementation is pretty simple only. We initialize the array, we initialize the max k, which is initially -1, and now it will be storing the max means AND of those elements which are not means at their correct position, and we initially assume that the sorted is true. Okay, now if nums of I is not equals to I, we'll simply make this is sorted as false, so that we know like we do not need to return 0, we will be returning this result. Now if it is the first element that we encountered that nums of I is not equals to I, we'll update it with that element, else we have already encountered. So if this is the x1, then we'll update max k with x1, and for further elements we'll be simply taking the AND, so that it will become x1 and x2 and so on. Okay, and now in the end we'll simply check if is sorted remains true, that means all the positions, all the numbers are in their valid positions, so that means we'll simply return 0 in this case, or else we'll return max k. So this will be like the big of n solution for this problem, and we have not used any space, so the space is constant. So I hope like the entire like you were able to grasp the discussion as well as the derivation of the means how we proved that we simply take the AND of those elements which are not at their correct position. Let's try to submit this code and see how much time it takes to run. It will run like pretty fast. I think let's see. It runs in 0 ms, so yeah, this beats 100% of solution, and that is like the most optimal approach to solve this. So I hope you were able to like follow along with the discussion, and if you did, make sure to like as well as subscribe, and if you yet have any doubts remaining in any of the parts, then make sure to comment down. I will be happy to respond. Thank you so much for watching.